Today we're looking at the quotient rule. Okay, we're going to be looking at the quotient rule. Let's have a look at it. So, we've got our first example, which is if you've got y is equal to x squared minus 5 divided by 2x plus 1. Okay. There is a way of doing this without using quotient rule. Okay. However, we do prefer to use quotient rule. The way to do this without quotient rule is to identify that this can be rewritten as y is equal to x squared minus 5 times 2, times 2x plus 1 to minus 1, and applying product rule to it. Okay. I don't know why we bother not doing that off the top of my head. I think there's a reason, but I can't think of it right now. But there is a way of dealing with it just as a division. I think sometimes it's not as easy as 2x minus 1, like the quotient rule might be slightly more complicated, and then changing it to product rule might be a bit more hard. I think that's one of the reasons why. But basically, similar to product rule, we consider the two different functions that are being divided in this case as u and v. Okay? And we can say that dy by dx is equal to v du dx, so very similar to product rule, minus u dv dx, so instead of plus this time, it's a minus, all over v squared. Okay? And that's what you do. So if we consider x squared minus 5 as u, so u equals x squared minus 5, then we can say du dx is the differential of that, which is just 2x. If v is 2x plus 1, then dv dx is just 2. Ooh, move that away from me. And then just applying these four different versions into this form gives us dy by dx is equal to v, which is 2x plus 1, so 2x plus 1, times du dx, which is just 2x, minus u, which is x squared minus 5, times dv dx, which is 2, all over v squared, which is, that changed for fun, which is 2x plus 1 squared. Okay? At that point, from here, you just simplify that down. So we do some expanding to get 4x squared plus 2x minus 2x squared plus 10 all over 2x squared plus 4x plus 1, or just 2x plus 1 squared. Let's just leave it like that. Okay, which gives us 2x squared plus 2x, plus 2x plus 10 all over 2x plus 1 squared. And you can consider the factorization of this. Is there a way of factorizing this so that we end up with a 2x plus 1? Why would I want to get a factorization of 2x plus 1? So I can cancel out, yeah. So because it's an algebraic fraction, on the bottom we got 2x plus 1 squared. The only way this would ever simplify is if on the top I could get a bracket of 2x plus 1, okay? Which you can't, okay? But in the textbook they go on to, for some reason, simplify this down to this, which is completely unnecessary because it doesn't progress anything. And x squared plus x plus 5 does not factorize. Okay, so you wouldn't have to factorize that. Cool? Is that all right? Okay, so that is the quotient rule. Again, just like the product rule, it's just about remembering this and then identifying that u is our numerator, and v is our denominator. Cool, that's it. I could do another example, it's the same on the second example. No real difference. So, maybe just do 4b. I feel, unless you've got any questions, anyone have got any questions? What?
So how come you just...
Why don't I do that?
Yeah.
You can, and do product rule.
I know, but like, for
What?
the question,
What?
so you don't... Question
V is just the denominator. So v isn't 2x plus 1 to the power minus 1. V is just 2x plus 1. It's what's on the bottom. Okay?